My name is Stefan Krauter. I'm a professor at the University of Paderborn for electrical energy technology and sustainable energy concepts. I'm working since 30 years on photovoltaic energy systems. While I understand the basic concept of that movie, Planet of the Humans, that is to reveal greenwashing, I have some remarks to make, which I will present in short sequences of the movie.
What better place to check out how our renewable energy revolution is coming along than a solar festival in the Green Mountain state of Vermont, powered by 100% solar energy.
Solar.
But then, a little rain began to fall. My cameraman noticed some commotion behind the stage.
What you guys set up here? This is our buyer needs the generator just in case we lose the power.
Oh, so the festivals run off solar energy primarily?
Primarily. We do need to bring some of this stuff in just because we want to make sure we have enough power to not kill our fancy toys that we have lighting the stage.
But the biofuel generator wasn't enough, so they wound up plugging into the electrical grid that we all use. That was disappointing. But after all, it had been raining.
We saw a sequence of a solar-powered movie festival, which obviously only worked during sunshine, but not in the rain. This is not a problem of photovoltaics. I live in Germany, we have a lot of rain there and a lot of systems working. So the designer of the systems wanted to save money, obviously, and has chosen too small area to power the festival under own conditions.
It's as simple as that.
The batteries are in the trunk?
No, the battery in this particular design is a T-shape right down the center, because everybody thought we killed the electric vehicle. No, we didn't. It's alive and well.
So what's charging the batteries right now? What's the source of
Well, here, it's coming from the building.
I mean, is it, what's our mix of power?
Oh, actually, Lansing feeds the building.
What's that?
Lansing feeds power to the building. So I don't know.
Yeah, right now the car is charging off of your grid.
Right. It would be charging off our grid, which is about 95% coal.
I don't think coal is bad. The what?
A big battle. Mountaintop removal.
Oh yeah.
Yeah.
It's got lovely BTUs. It's got lovely
Very
energy
dense,
value.
yeah.
How do you burn it more cleanly?
Everybody knows that an electrical vehicle should be charged by wind or solar energy or other renewable energy sources, not by coal energy, because otherwise it doesn't make sense in reduction of carbon dioxide emissions.
I decided to take him up on his offer to check out their football field-sized solar array right down the street.
What we're trying to do with this kind of a tour is get a sense for what they've already done as an indication of what we could do to push the envelope even further.
You know, around here there's not any real good wind. That's what we liked about solar. You would get the power when you most needed it. Pass these around, look at them. They are pliable. Made in Michigan, that was another good thing. Although the efficiency of these panels is only about just under 8%. If you happen to be NASA and you happen to own a rover running around Mars, they have very efficient panels. But we can't afford those at about $1 million a square inch. The standard answer that we tell everybody is we're providing enough to meet the peak requirements of 50 homes. For most of the people that look at it a little bit closer, we generate about 64,000 kilowatt hours a year. Our average customer uses about 6,000 kilowatt hours a year. 6,000 into 64 is just a little over 10.
We saw a photovoltaic power plant with modules with an efficiency of 8%. This is totally outdated. Even cheap solar modules nowadays have a conversion efficiency of 16%. That means they need half the area. High efficiency solar cells have an efficiency in the vicinity of 20%. The thing he said that more efficient solar cells would be a thing of NASA and would be unbearable in costs, it's a lie. Also, the way they set up this power plant has been of installation of PV modules. How is it done nowadays?
Just half an hour by car from Bordeaux is one of the largest photovoltaic building sites in the world. The modern, high-tech solar park extends over an area of 2.6 million square meters, the equivalent of 363 football pitches. Thanks to the maximum output of 300 megawatt peak, approximately 111,000 households can be effortlessly supplied with electricity. As a result, approximately 230,000 tons of CO2 are saved each year in comparison with a coal-fired power station. The ground screws are screwed into the soil with millimeter precision. The fully automated process and the special ground screw drivers developed by Krinner make it possible to position the ground screws rapidly. The material-optimized patented design of the support frames adapts perfectly to the local condition. Finally, the photovoltaic panels are quickly and easily assembled with a plug-in system developed especially for this purpose. Thanks to cutting-edge technology and efficient working steps, more than 4 megawatt peak per installation team can be assembled each day. In addition, the support frames are completely maintenance-free after assembly, which means no subsequent costs.
The thing is you've got to have a fossil fuel power plant backing it up and idling 100% of the time. Because if you cycle up or cycle down as the demand on the wind comes through, then you actually generate a bigger carbon footprint than if you just ran it straight.
Do you ever go to things where they just go, well, that's not true, it doesn't matter, we're going to have the smart grid?
Doesn't make any difference. You still got to have it idling, because let's just say the wind stopped right now. Just stopped for an hour. You've got to have that power.
Richard York of the University of Oregon published a study in the journal Nature in which he posed the question, do non-fossil energy sources actually replace fossil fuels?
Well, we implicitly assume often the substitute pushes out the thing you want it to substitute for. What you find is nations that add non-fossil energy sources do not seem to see a particular suppression of fossil fuels.
Here we saw an example of non-flexible coal power plants. Formerly, coal power plants were not able to throttle down a lot. They have to stay idle with a considerable consumption of coal. Nowadays, this has changed. Companies are investing more and more to make the coal power plants flexible, or even to substitute them by gas power plants, which are much more flexible, which can throttle down and ramp up much quicker.
I'm in a strange position. I'm against our addiction to fossil fuels and have long been a fan of green energy. But everywhere I encountered green energy, it wasn't what it seemed.
This is like a perpetual energy battery.
And where do you get the hydrogen from?
The hydrogen, hydrogen is sourced from any hydrocarbon material. So you can get it from natural gas, you can get it from any petroleum or oil-based product material.
I read about a zoo that was said to be powered by elephant manure. But it turned out the elephants didn't even produce enough manure to heat the elephant barn.
That we don't even really make enough, and we have elephant-wise, to even do that. We would need a lot more.
More elephants.
Yep, more elephants, more manure.
What we saw here was basically a repetition of the electric car. So if the hydrogen isn't coming from renewable energy sources, it's useless. The guy who wanted to sell that car didn't care about it. He was even suggesting that the hydrogen could come from fossil fuels. The example with the elephant was unnecessary.
Ethanol plants also seem to have a secret ingredient.
This is the most productive farmland in the world, and we're not that far west of the biggest coal mines in the world as well. So bring the two together and get an ethanol plant.
Great. So ethanol was reliant on two things: a giant fossil fuel-based industrial agricultural system to produce corn, and even more fossil fuels in the form of coal. All of this in the attempt to replace fossil fuels? It was enough to make my head explode. I was getting the uneasy feeling that green energy was not going to save us.
that movie. In general, the amount of energy you need to produce a kilogram of ethanol in terms of space is much more than if you would have installed solar panels or PV panels and would have charged an electrical car rather than to ethanol fuels. It's not a problem of green energy, but you have to make sure that the energy is really green. Just do certification, look where the thing is coming from, but it's not anything in general against it. It's the way how it is done, but not the principle.
I hear a lot of times that solar cells are made out of sand.
Have you ever thought about solar panels? The main ingredient that makes them work is silicon or sand.
This is the raw material chips are made of, sand.
They don't use sand at all. So they use, I'll show you what, this is one of the ingredients. It's actually mined quartz.
Spruce Pine, North Carolina, regarded as the finest source of high-purity quartz in the world for semiconductor, solar, and communication applications.
But you can't use sand because sand has too many impurities. So you start with a very high-quality quartz and a very high-quality coal. And then you put those two together into an arc furnace and you melt them.
The quartz is then melted with coal in a large furnace at temperatures of up to 1,800 degrees.
So you need more coal to do that. I'll get another coal out. So when we melt these together, we get silicon metal and carbon dioxide. And the carbon dioxide just goes off and you got rid of the carbon, you're left with silicon metal.
This sequence tried to show that for producing silicon, it would be absolutely necessary to use coal and even more coal to heat it up. That's not true. You can heat up without using coal, for example, using electrical energy.
Coal plants were closing, but Ozzy explained that well-meaning people were being misled.
NV Energy is now going to go ahead and shut down the plant and go with Renewable, one of the largest solar plants, and that's going to happen right behind me.
Since you can't replace a coal plant with solar, they're actually replacing the coal plant with 2 natural gas plants. And natural gas is a fossil fuel. This is the Las Vegas cogen natural gas plant. This is one of the facilities that's replacing the coal plant that's being shut down. This is the Sun Peak generating facility. This is the second natural gas plant that was used to replace the coal plant. And you hear the same story in Iowa.
Instead of using energy generated by coal-fired power plants, the solar farm will now avoid about 2.1 million pounds of carbon pollution.
But then they're building a larger natural gas plant. This is a 650 megawatt natural gas plant. That's 4 times more megawatts than the coal plant over there that it's replacing.
This sequence is even manipulative. It says that the coal power plant is substituted by a fossil fuel plant which is even bigger than the coal power plant. What they didn't mention that first gas power is only half of the emissions as a coal power plant, and gas power plants are more flexible. So you possibly won't run them at many full load hours, it's called. So usually you use the gas power plants only as a so-called peaker. That means you just use them when there's no wind and no solar power available and the demand is really high. The rest of the year it's shut down or throttled down and therefore not emitting carbon dioxide, which is much more difficult than coal power plants or even not possible. This hasn't been mentioned in that sequence, so it just talks about the theoretical maximum power of those power plants and implied that's related to the carbon dioxide emissions. He didn't mention the duration of use.
And they're doing the same thing in North Carolina, which was the subject of that Years of Living Dangerously series.
Duke Energy operates a coal plant right outside of Asheville that is the biggest source of climate pollution in western North Carolina. And we are working to retire that plant and replace it with clean energy.
But what they don't tell you is that we're also building a larger natural gas facility.
So we'll be retiring the 2-unit, 376 megawatt coal plant. We'll invest $750 million to build a state-of-the-art natural gas plant.
When Michael Brune stands up and talks about clean energy, he's using solar cells and wind turbines.
This is the new world, 100% clean energy.
When Michael Bloomberg stands up and says cleaner energy, he's talking about natural gas.
Create cleaner energy, solar, wind, and natural gas.
In fact, the Sierra Club's Beyond Coal campaign actually coincides with one of the largest expansions of fossil fuel production that we've ever pulled off, most of that being natural gas.
So it's basically the issue as for the sequence before, just telling that gas power plants will emit more carbon dioxide. Usually they are not used as the same regime as the coal power plants. They are not a baseload power plant, they are peakers. And so in total they would release less carbon dioxide because they are only used during peak periods. The US fossil fuel production is increasing. It has to do with a lot of fracking products which are exported. Germany was asked by the United States to build even a terminal to use that fracking gas. So what he didn't mention that gas power plants can be also powered by so-called green gas. So you can make hydrogen or even methane, that means natural gas, out of renewable energy. Just by electrolysis, just you electrolyze water and form it to hydrogen and oxygen. And with additional carbon dioxide, you can create methane. And this process it's called power to gas and could be used to power the gas power plants so they don't have to stay fossil. They can go green. There just has to be an incentive to do that.
What's stopping us from running the world on 100% solar and wind?
Well, intermittency is one of the major challenges.
When we add solar cells or wind turbines to a grid, do we get to shut off a coal plant?
That's certainly the goal. The problem is, or the difference is that renewables are intermittent. All of a sudden a cloud cover could come over and your solar generation could drastically decrease. And if you don't have something else there to meet whatever the load is at that moment, then you're going to have power outages.
So we don't get to turn a fossil fuel power plant off when the sun is shining or the wind is blowing?
Well, it's not that easy. We need to be able to back up that power to keep the system steady all the time so it doesn't collapse. Most likely that's through fast-acting gas plants, but also what we call the baseload plants, either nuclear or coal, that are on all the time.
So what they said here is same as before. You need a flexibility. Just you have to have adequate power plants which are able to start up quickly. This is also well known since a decade, and the manufacturer considered that as well as the coal power plants as well as the gas power plants.
Does it affect the efficiency to turn fossil fuel power plants on and off?
Oh yeah, they don't like to be dialed up and down.
Turning them on, turning it off, there's energy used and lost in any time. Kind of like when you turn on your car and off, you use a little extra gas to get it turned on. I do still think you have to maintain a base load of some kinds.
What's the solution then?
You need energy storage.
Without storage, you can't count on it.
If you can store the energy that's created off of things that are intermittent, like solar and wind, you can store that, then you're reducing your need for a baseload.
But would adding storage like batteries increase the carbon footprint?
Yeah, absolutely.
When I looked up how much battery storage there is, it was less than 1/10% of what's needed. In a couple years, they begin to degrade and need to be replaced a few years later.
This statement ignored the development in battery technology. While 10 years ago, a lot of material and a lot of energy has been needed to manufacture lithium-ion batteries, the situation changed. Along with that, the price has been drastically reduced. 10 years ago, 1 kilowatt hour of storage capacity of lithium-ion battery costed $1,100. Nowadays, this is available for $125 already. It wasn't mentioned that storage or a backup isn't the only solution. Another thing what is really helpful is the so-called demand-side management. Not all industrial process or even process in a household have to be done during nighttime or so. You can really adapt them to the availability of renewable energy sources. This is called smart grid. So you just switch on your washing machine or your dishwasher when there's lots of sunshine and delay them when there is no sunshine available. This reduces a lot the necessity for storage.
I learned that the solar panels don't last forever either.
Some solar panels are built to last only 10 years.
Then there was in the last part of that sequence, it was mentioned that some modules only last 10 years. That's absolutely nonsense. Formerly, the warranty of a module manufacturer has been 20 years. This has been extended to 25 years. Nowadays, even with double glass bifacial modules, some module manufacturers are giving 30 years of warranty. So 10 years is absolutely nonsense. Because solar electricity got so cheap, it doesn't make sense at all to exchange them after 10 years, because sometimes the installation costs are even higher than the costs for the modules.
The sun is renewable, but the solar arrays are not.
Oh, come on. There's got to be something renewable.
So,
glass is renewable.
Glass is not renewable.
Iron's renewable. Aluminum, that's renewable. I recycle my pop soda cans. I know it's renewable.
Yeah, the problem with all of these materials is that it takes an incredible amount of energy to mine and process all of the materials that go into building something like this. You use more fossil fuels to do this than you're getting benefit from it. You would have been better off just burning the fossil fuels in the first place instead of playing pretend.
That green energy has nothing to do with fossil fuels is apparently a story only meant for you and me. Here is Robert F. Kennedy Jr. speaking to oil and gas company insiders.
It's a combination solar gas plant. The plants that we're building, the wind plants and the solar plants, are gas plants.
In this sequence, there was a lot of nonsense. First, sure, glass is recyclable, aluminium is very much recyclable, and so on, other materials are recyclable. Also, for getting the materials, you don't need necessarily fossil fuels. Many countries like Norway or Iceland, they only have renewable energy, so any aluminium produced in Iceland is renewable. Also, the amount of energy needed is captured within the so-called Energy-Payback-Time. The amount of people have made a lot of studies and calculations how much energy you need to produce a solar panel, including the mining of the raw materials, including the recycling processes. And they found out that the energy you harvest within 1 year only is sufficient to cover that initial energy to produce them. The use of solar energy is steadily increasing. In 3 years from now, we will reach an installed nominal power of 1 terawatt. Further 12 years, we will reach installed power of 18 terawatt. That's sufficient to power the whole world with solar energy only. You won't need any other source of energy. The use of energy will be more efficient because a car with a combustion engine will waste about 70% of its energy, while a car powered by solar energy or by photovoltaic electricity will use about 80 to 90% of its energy. Also same for heating. You can do heating much more efficient with heat pumps rather than to burn fuels in order to heat. This also allows a saving in the vicinity of 70%. Thank you very much. I hope my comments have been helpful. You are welcome to add further comments here under this video.